Hi there, my name is Dana and I'm an educator with the Virginia Aquarium, and today we're going to talk about pH. Now pH is a scale from 0 to 14 and it deals with the amount of or concentration of hydrogen in a substance. Substances with a lot of hydrogen or a bigger concentration of hydrogen fall between 0 and 6 on the pH scale. Right in the middle of our scale we have neutral, which is 7. And then substances that don't have as much hydrogen or have a weaker concentration of hydrogen are basic or alkaline. All right. So some examples of acidic substances, maybe you can name some. So substances that are acidic, if you were to taste them, they usually taste a little sour. So lemon or lemon juice, oranges, grapefruit, those are all excellent examples of something that is acidic. Also coffee and tea tends to be acidic as well. Right in the middle of our scale are neutral substances. Perfect example of that would be distilled water, usually has a 7.0 pH. And then bases, can you name me maybe an example of a basic substance you're familiar with? Basic substances, if you were to touch them, they usually feel a little slippery. So examples of that would be soap, maybe laundry detergent, bleach and ammonia. Those are examples of bases. Now on our pH scale, it's really interesting. It's actually a logarithmic scale where one increase in pH represents a 10-fold increase in pH. So a substance with a pH value of 5 is actually going to be 10 times more acidic than a substance with a pH of 6. So how much more stronger would this be? So if you had a pH value of 5, how much more stronger in pH would it be than a substance with, let's say, maybe a pH of 7? It would be about 100 times more acidic. All right, so we're going to talk about acids and bases, and I'll have a fun demonstration to show you at the end of the video. All right, so why is it so important for us here at the Virginia Aquarium to know about pH? Well, when we talk about water quality, one of the important parameters that we investigate is the pH of water. We know that a lot of living organisms prefer to have a neutral pH. So it's really important for us to track that, all right? So to help us determine the pH of a substance, we tend to use something called an indicator. An indicator is a special class of chemical that reveals the pH of a substance by changing color, all right? So one example of an indicator is one that I have here. It's called Bojan Universal Indicator. Another example of a universal indicator is cabbage juice. So maybe you've played with this demonstration where you've created or made cabbage juice indicator. Cabbage juice contains something called anthocyanins, which is a pigment that changes color depending on if it's mixed with an acid or a base. My universal indicator does the same thing. What's so cool about it and convenient is that when it mixes with an acidic substance, let's say with a pH of 4, it'll change to a red color. If it mixes with a substance with a neutral pH of 7, it'll actually change to a green color. And when it mixes with a strong base or an alkaline substance, it'll actually turn a deep blue, maybe even a violet color. So universal indicator like Bojan and cabbage juice is really convenient. So what I have before me right here on this table are examples of different household items, and I'm going to test the pH, and maybe you can make a good prediction about what you think the pH value is going to be. All right, so I've got my gloves on and be extra safe. My first substance we're going to test is lemon juice. All right. So I'm going to pour a little bit of my universal indicator into this dish right here. And notice the color of a universal indicator. It has a color of its own. It's a nice emerald green color. It's really pretty. But we know that it's going to change color, so I'm going to put some in my pipette here. Now, lemon juice, think about it. What do you think the pH is going to be? Acidic, neutral, or basic? All right. I'm going to add a few drops. What color is it changing? So it's a beautiful red color. And what I'm going to do is hold my scale up. I'm going to look at that and say that the pH value of lemon juice is going to be between maybe 4 and 5. So we say that's acidic. All right. And we know that, right? When you drink lemonade, it tends to be a little sour. All right. So my next substance or solution that I have here is a baking soda solution. So all I did was mix in a whole bunch of baking soda. So I created a super saturated solution and I poured a little bit into here. So make a prediction. What do you think baking soda's pH value is going to be? Is it going to be acidic, neutral, or basic? Interesting. So that's a really beautiful kind of greenish blue color. So it looks like it's falling on a pH value of 8. So what does that mean our pH value is going to be? Basic, right, or alkaline, all right? The next one I have is rubbing alcohol, all right? So really think about that, rubbing alcohol. Do you think that's going to be acidic, neutral, or basic? Got my indicator here. Oh, add a few more drops to it. So here's my scale. It's actually a pH value of 7, which is neutral. Now that's interesting to think about because when you put rubbing alcohol on a cut, you know, it burns. So there's that tendency to think that, oh, it's an acid, but it's actually neutral, okay? All right, the next one I'm gonna try, I've got my safety gloves on when I'm handling this one. This is ammonia, all right? Ammonia is it's used for cleaning, right? If you're not familiar with it, that's okay. But maybe you are familiar with it and you can make a guess. Told you it's a cleaner, what it's used for, so maybe you can make an educated guess as to what you think the pH value is going to be. All right, add my drops here. Wow, look at that. It's a beautiful purple color. Hold it up here, and it's actually beyond my scale here. So the pH value of ammonia is going to be somewhere between 11 and 14 pH. That's a very strong base, and that's why it's used for a cleaner, all right? So I have this beautiful spectrum of colors here. They all have different pH values. The most important one I saved for right here. This is tap water, okay? What do you think my tap water value is gonna be? So it's a nice light green color. And just as we kind of anticipate, it's gonna be a pH value of 7, so that's nice and neutral. Okay, so that's cool. That's the beauty of universal indicator. It actually changes color and it gives you a nice beautiful spectrum that we have right here. Now there are actually many different types of indicators, and what I have over here is my favorite one. First off, the name is pretty cool. It's called phenolphthalein. Can you repeat that after me? I'll say it one more time. Phenolphthalein. Yeah. If you look at phenolphthalein, unlike universal indicator, it's clear and colorless. Phenolphthalein is an indicator that changes color only in the presence of a base. So if I were to mix phenolphthalein with water, it would remain clear and colorless. If I mixed phenolphthalein with an acid, it would actually remain clear and colorless, all right? I'm gonna do a fun demonstration just to show you what color phenolphthalein changes when it mixes with a base, all right? So I've got a cylinder right here, and to my cylinder, I'm gonna add a basic solution. Now remember, phenolphthalein will only change color in the presence of a base. So I'm gonna open this up. I'm gonna get my pipette here, and I'm gonna add a few drops. Now what color is my basic solution? It's clear and colorless, right? So I've got clear plus clear. Watch what happens when I add this indicator. Wow, it changes to a beautiful magenta pink color. How beautiful is that? So I'm gonna try to mix this up a little bit better. So there you have it. Phenolphthalein only changes color in the presence of a base to this nice, beautiful magenta color. Now think about it. If I want this to go back to clear and colorless, what do I need to do? I need to add an acid, right? Because if I add acid to this solution, eventually it'll move its way up the pH scale to neutral, and then it'll push into acidic, and then it'll go back to clear. So what I have here is vinegar. Vinegar is a very common household acidic substance. I'm gonna pour my vinegar in here, and presto, we've got clear and colorless again. How cool is that? Now I'm gonna do this one more time in a different way, all right? I'm gonna get another cylinder. I'm gonna add just a little bit of my basic substance again. Just gonna repeat what I just did, but I'm only gonna use a little bit. Now, just as before, when I added my phenolphthalein indicator, it's gonna go from clear to magenta. And just like I said before, if I want that to go back to clear and colorless again, I need to change the pH and make it either neutral or acidic, all right? Now, instead of just pouring vinegar back into it, I'm gonna do this a different way, all right? But I'm gonna put my safety goggles on first. I'm gonna get a straw here. take a big, deep inhale in. Take a second breath. What's happening? Take one more breath. Maybe one more, but you see what's happening, right? It's going from that darker pink color to a lighter pink color. Almost virtually clear again. So what is going on? Well, obviously I'm changing the pH, but what am I doing? Well, I'm exhaling into the glass, right? What's the name of the gas that we inhale that's really important for us? It's oxygen, right? Can you name the gas that we exhale? Carbon dioxide, right? So when I exhale into this solution, I'm exhaling my carbon dioxide gas, and it's actually dissolving into the liquid, creating something called carbonic acid. Carbonic acid changed the pH of my substance, and it made it clear, or almost clear. I think I need a little, maybe one more exhalation, it'll be totally clear, but you can see the color change. So carbonic acid sounds kind of scary, but it's actually in your soda. It makes soda acidic, and it also gives you that carbonation that you're familiar with. So that's a really fun demonstration that you can try with your cabbage juice indicator. So you make a basic substance, maybe out of a saturated baking soda solution. You add your cabbage juice indicator to it, you exhale into it with a straw, and it'll actually change color. It won't go from pink to clear and colorless because that's phenolphthalein, but you will see a color change with the cabbage juice indicator. I hope you all enjoyed that. My name is Dana and I'm with the Virginia Aquarium. Thanks for joining us.